Folks, we are back with the miscellaneous exercise now, and let's finish this voluminous miscellaneous exercise, which like the exercise 6.5 appears to be a little more voluminous. Let's start right away with the question number 1a. It says that using differentials, find the approximate value of each of the following, and in that the first one they give us 17 over 81 whole raised to 1/4 root. So we have whether we remember what we have done in the approximations is always for the given value we try to find out a standard value which is close to this value and then use that in order to get, that's why it's called approximating. So we find out a standard value which is close to this value, and from there we will use it to find this value, approximate value of this given function. Now because it's a fourth root, let us define the function. Let y be fourth root of x. We have to define the function on the basis of the function that's given to us. The number that is given to us will help us to define the function. Right away, let's find the derivative. Dy by dx is going to be 1/4 x raised to minus 3 over 4y, because n x raised to n minus 1. That's how we take the derivative. Now let's fix all the standard values and all that. So the standard value that is close to 17 over 81 is 16 over 81. 16 over 81's fourth root you can easily find. So that's the standard value that you're going to check. So 16 over 81. Why? Because we can find the standard value. How? Because if you have to find the fourth root of 16 over 81, it is 2 raised to 4 over 3 raised to 4 and its fourth root. So like that it will come to 2 over 3. So you are able to find. You have to find out, you have to fix that value of that as x, whose y value you can easily find. And x plus delta x is your given, that is 17 over 81. And y plus delta y again is what you have to find. 17 over 81, the fourth root. So we easily know what is delta x. That is x plus delta x minus x. So 17 over 81 minus 16 over 81, that is 1 over 81. And we may also have to find the dy by dx at the point x, that is 16 over 81. Let's find that. Dy by dx is 1 over 4 times x, which is 16 over 81 raised to minus 3 over 4. Now this is very clear to us that 16 over 81 is 2 over 3 whole raised to 4. So you are going to get 2 over 3 whole raised to negative 3 or 3 over 2 whole raised to positive 3. We have learned law of exponents. If you want to make the exponent positive, just inverse these. So it's going to come to 1 over 4, 3 cube, which is 27, and 2 cube, which is 8. So you're getting 27 over 32 as the dy by dx. Now, why are we doing all this? Because we know the relation here. The relation is delta y is y plus delta y minus y. And in turn, this delta y is dy by dx times delta x. So this relation we are going to use for us to find the value of 17 over 81 and the fourth root. So dy by dx, we know the value, it is 27 over 32. We are going to pick up all and write here. Delta x, we know the value 1 over 81, and y plus delta y is 17 over 81 fourth root, which we have to find. And y value, we have found it out, and that is 2 over 3. So since we know all the values, it's just to find it out, right? So let this be here. Let's shift that on the other side. 17 over 81 whole raised to 1 over 4 is going to be 2 over 3 brought on the other side, plus this can cut, okay? 27, 3, 9 times, 9, 3 times, 9, 9 times. So finally 3 times, yeah. So it is 1 over 32 times 3 actually. So in order to equalize this, you just have to multiply by 32. So on both numerator and denominator. So it's going to be 64 plus 1 over 32 times 3 means 96. So 65 times 90, 65 over 96 is going to be your 17 over 81 whole raised to 1 over 4. We can get the division of 65 over 96 and get the answer. When we divide it, it will come to 0.677. That is the value that you get on dividing. Now let's right away go for the B sub question, in which they say that you have 33 raised to 1 over 5. So as we did there, let's make the assumption, let y be x raised to 1 over 5. Now it's very clear to us that x plus delta x is 33, but x is going to be 32 because fourth root of 32 is 2. You know the value. So we can quickly fix those values. So here, yeah, here you can have x as 32. So you'll get the y. Y is 32 raised to the fifth root. Now 32 is 2 raised to 5. So like that, if you write it like that, you get your y value as 2. And your x plus delta x is what they ask. So that is 33. So that way your y plus delta y is going to be 33 and the fifth root. Now therefore we can also find delta x. It's very clear to us that delta x is going to be 1 because x plus delta x minus x. Now dy by dx also let's find and keep. Dy by dx at x equal to 32. See, when y is this, dy by dx is going to be 1 over 5 x raised to 1 over 5 minus 1, which is minus 4 over 5. So let's get the value 1 over 5, 32 raised to negative 4 over 5, which is 1 over 5, 32 we know is 2 raised to 5. So 2 raised to 5 times minus 4 over 5. So that's going to be 2 raised to in the denominator. So 5 times 2 raised to 4, which is 16. So you have got dy by dx. Since we know that delta y is y plus delta y minus y, and this in turn is dy by dx times delta x. So let's quickly make the substitutions and get the answer. Dy by dx for us is 1 over 5 times 16 delta x. Where is our delta x? Delta x is 1 for us, and y plus delta y is what we need to find, 33 raised to 1 over 5. And y, where is my y? Y is 2. So what is our 33 raised to 1 over 5? We are going to take the 2 on the other side. So it's 2 plus 1 over 16 times 5, which is 80. So 2 times 1 over 80. So when we equalize, 2 plus, when we equalize times 80 times 80, so it's going to be 160 plus 1 over 80. So 161 over 80. That's the answer. Okay, and if you want to quickly find it out, we can find it out. 161 over 80 is going to be 82 times 160, and the 1 is left, which we are not able to do anything. So we can put a decimal point and get a 0. Again, not able to do because it's just 10. So put a 0, get one more decimal, 2.01 or so. Yeah, that's your 33 raised to 1 over 5. So that's about the solving. I don't know, I will just make a small case over here. That's our approximation, something that we did in the earlier exercises. Beautiful and very tailor-made. Now you have to follow the steps properly, and this is how you get. So that's all for this video where we do the approximation problem. In the next video, we come up with the question number 2. Bye-bye till then. Thank you.